Okay, here we go again. We're moving to the next section, integration by substitution. And here, all we're doing is we're following the prescribed method of our u substitution. I have 4 to the x e to the x squared dx. You first identify the inside function. The inside function right here is x squared. And so we let u equals u equals x squared. We find the derivative, du dx, which is going to be equals to 2x. We solve for dx, which means that these two things right here switch places. And so you would have then that du divided by 2x is equals to dx. And then we use the first line and the last line, and we substitute them both back into the original problem. After doing so, this should simplify our integration and make our life easier. So in making the substitution, I will have the antiderivative of 4xe. I am substituting, so I will have the u, and then I am substituting. I will have du divided by 2x. I simplify, 2x goes into 4x twice, because the x's cancel, and then 2 goes into 4 2 times. So this is simply 2 times e to the u du. The antiderivative of e to the u is e to the u, right? The antiderivative of e to the u is e to the u, and so therefore that is 2e to the u plus c. The last step is to undo the substitution. So this is 2e to the x squared plus c. If I were to take the derivative of this, I would get back my original problem. 4x e to the x squared. So that's number 13. Number 14 is the antiderivative of 3 times 9x squared plus 12x minus 2e raised to the 3x cubed plus 6x squared minus 2x plus 5 dx. Sometimes it can be hard to figure out what's the inside and what's the outside function, but normally you go to the one that's the higher power, unless you have an ln. Generally speaking, when you have an ln in a function, you take the ln as your inside function. With that being said, let u equals 3x cubed plus 6x squared minus 2x plus 5. Du dx is 9x squared plus 12x minus 2. These two switch places. So that's going to be du over 9x squared plus 12x minus 2 is equals to dx. And then we use the first line and the last line as our substitutes. So this entire equation becomes the antiderivative of 3, 9x squared, plus 12x minus 2, e to the u du divided by 9x squared plus 12x minus 2. This comes here, this is your u. With that being said, this denominator cancels with this term, and again, the point here is that it simplifies to a simple antiderivative. The integral of this right here is simply 3e to the u d plus c. Again, our term of integration is u, so think of the u as an x. It's just a regular antiderivative. And then you make your change back. 3e, u is this long thing right here. And so that's going to be 3x cubed plus 6x squared minus 2x plus 5 plus c for the unknown constant. Whew. Number 15. I want the antiderivative of 6x plus 3 times x squared plus x plus 1 to the fourth dx. This is my inside function. Again, has the highest power of x. So let u equals x squared plus x plus 1. Du dx is equals to 2x plus 1. Hopefully by now you've gotten accustomed to this little pattern. Again, these two switch places. So that is du divided by 2x plus 1 is equals to dx. And then the first line and the last line gets substituted in. Integral 6x plus 3 multiplied by u. Instead of writing all of this, I just write u to the fourth. Instead of writing dx, I write du divided by 2x plus 1. And at this point, I can't, well, wait a minute, those two things aren't the same. I can't cancel them. Well, if I look carefully at this term, I see that I can factor out a 3. So that's the antiderivative of 3. That's a lot of questions. The antiderivative of 3, 2x plus 1, u to the fourth du. The 2x plus 1s will cancel. And so then it's the antiderivative of 3u to the fourth du. And that's 3u, add 1 to the power, divide, plus c. And so that's going to be 3, open parentheses, what was u again? X squared plus x squared plus x plus 1 raised to the fifth power, raised to the fifth power over 5 plus c, and that takes us to our answer. All right. Next question, number 16. Number 16, I have the antiderivative of 2x plus 4 divided by x squared, I'm taking the derivative in my head, divided by x squared plus 4x plus 1 raised to the fourth power dx. So let u equals x squared plus 4x. Is that 4x? Or am I writing the wrong thing? Oh yeah, it is 4x plus 1. Du dx is 2x plus 4. You switch and rotate. So du divided by 2x plus 4 is equals to dx. I get to substitute my little heart. 2x plus 4 divided by u to the fourth. Notice right here that this is u. It's being raised to the fourth power. So then that's going to be u to the fourth. And then I have du divided by 2x plus 4. Again, the question simplifies. The 2x plus 4s will cancel out. And so that's going to be the antiderivative of 1 over u to the fourth du. Again, this simplifies or breaks down to an antiderivative that you can then solve. And so that antiderivative is u to the negative 4 du, add 1 to the power, that's u to the negative 3 over negative 3 plus c, and that's going to be 1 over negative 3u cubed plus c, and then I gotta make the change. Instead of u, you write x squared plus 4x plus 1. So that's going to be negative 1 over 3 x squared plus 4x plus 1 raised to the third power plus c. Number 17 looks like more of the same, but actually ends up being a very different answer. Number 17, I have the antiderivative of a fraction one more time, 2x minus 3 divided by x squared minus 3x minus 6 dx. And so, oh, I got this. We're rolling now. Let u equals x squared minus 3x minus 6. Therefore, du dx is 2x minus 3. We know these two switch places. So I will have then that du divided by 2x minus 3 is equals to dx. Yeah, we're rolling. We know we take the first line and we take the last line and they put them in. This right here is going to become a u, and this right here is going to become du divided by 2x minus 3. So yeah, we got this. Antiderivative 2x minus 3 divided by u du divided by 2x minus 3. The 2x minus 3's will cancel. And so that's the integral of 1 over u du. This is the part that you have to remember what to do. The 1 over u is a special integral. The answer is, drumroll please, ln absolute value of u plus c. Did you remember that? And so therefore, it's going to be ln absolute value. I plug my u back in, x squared minus 3x minus 6 plus c. And there you go. It looked exactly the same, but our answers ended up being totally different. That is because of the single u in the denominator. Now, for number 18 and 19, it looks like I got the same question, but it wasn't meant to be the same question. I think I know what I wanted to do, so let's do them. Number 18 is, as stated, 5x to the 4 minus 3x squared plus 2 times the cube root of x to the 5 minus x cubed plus 2x raised to the 5th power dx. So we're going to let u be called inside function x to the 5 minus x cubed plus 2x. Hopefully you can get accustomed to what the inside function is. Du dx is 5x to the 4 minus 3x squared plus 2. To no one's surprise, exactly this right here. So we know they will cancel out. These two switch places. Du divided by 5x to the 4 minus 3x squared plus 2 equals dx. First line and last line gets switched out, and so that's the antiderivative 5x to the 4 minus 3x squared plus 2, the cube root of u to the 5 du divided by the 5x to the 4 minus 3x squared plus 2. Cos these cancel. I have an integral of 3, I'm going to write as u to the 5/3 du. You add 1 to the power, so 5 plus 3 is 8. So it's u to the 8 over 3 divided by 8 over 3 plus c. And that's going to be u to the 8 over 3 multiplied by the reciprocal, 3 over 8. It's a horrible looking 8. Plus c, and that's going to be 3 over 8, the cube root of u to the 8th power, plus c. And of course, I now need to replace u. Not replace you as in, you as the person, We're all valuable and we all care about each other. I mean replace the variable u. X to the 5 minus x cubed plus 2x raised to the 8 plus c. Number 19. Number 19, I'm going to do a bonus question for number 19 because it's the same question. And this question right here is, what question should I do? Let's try it. I'm not sure what the answer is. Let's try it. The antiderivative of ln of x dx. I don't know. I won't respond by no one. If you let u equals ln of x dx, then du dx. No, I think this question is solved by parts. No, du dx is 1 over x. So therefore, no. It's not the problem I want. Problem I want is this one right here. It is going to be x divided by x plus 1 dx. There we go. Then let u equals x plus 1. Therefore, du dx is going to be equals to 1. Therefore, du is going to be equals to dx. And so, when I substitute, I get the antiderivative of x over u multiplied by du, correct? But this x doesn't go away. But from this line right here, we can see that u equaling x plus 1, if I minus 1 on both sides, u minus 1 is equals to x. So this becomes u minus 1 over u du, which is the same thing as the integral of u minus 1 u to the negative 1 dx when I move the u up. Oh, sorry, du, not dx. And so that's going to be distributing 1 minus u to the negative 1 integral du, and so that's going to be u minus ln absolute value of u plus c. And of course, u is equals to x plus 1, and so this is going to be x plus 1 minus ln absolute value of x plus 1 plus c. And there's your bonus question. Good luck.